Hello Miss, today for FIS 3122 Physics Lab, we are going to look at case study, which is the individual assignment, experiment presentation. For this topic, we are going to look at the experiment 5 that we did in our lab manuals, which is simple harmonic motion. So, first up, we are going to look at the objective of this experiment. The objective of this experiment is to determine the acceleration due to gravity using a simple pendulum model and to investigate the effect of large amplitude oscillation. So we're going to use the experiment of simple pendulum, and we are going to calculate the acceleration due to gravity. So to conduct our experiment today, we are going to look at the apparatus that we are going to use to conduct our experiment. First up, to do our experiment, we're going to need a retort stand. But instead of a retort stand, we are going to use a metal ruler to act as a retort stand. Next up, we are going to use a metal ball or a metal object that is going to act as a mass or load as pendulum. And then we are going to use a stopwatch to calculate the time taken for the oscillations, and then a protractor to measure the angle of propagation of the pendulum. That's all for the apparatus. Now we are going to conduct the experiment. Okay, so now that we have set up the experiment as per shown in the procedures, now that we are going to conduct the first experiment, which is part A, 20 oscillations of pendulum with different length. So first, for this experiment, the pendulum was released from the angle of 10 degrees. So we use the protractor in order to find the angle of the pendulum, and the angle was released at 10 degrees angle, and the pendulum was released. And the time taken for 20 oscillations is recorded using a stopwatch. And this experiment was repeated 5 times with different lengths of pendulum, and the period of time for different length of pendulum is recorded. So now we are going to look at the part B of the experiment. For part B, the length of the pendulum is fixed at 1 meter, and the angle of the propagation of the pendulum is fixed at 70 degrees, and the time taken for 5 oscillations is recorded using a stopwatch. So again, we are going to use the protractor to calculate the angle of propagation, which is 70 degrees, and the pendulum was released, and the time taken for 5 oscillations is calculated. Okay, so now that we have conducted our experiment and we have gotten all the data from the experiment, now we're going to record all this data into tables. So first, we are going to record the data for experiment part A, which is the 20 oscillation with different lengths of pendulum at a 10 degrees angle. So this is the table for that data. Next up, we are going to record the data for experiment part B, which is the 5 oscillation with same length and angle of 70 degrees. So after recording the data in the table, we are going to plot a graph of t squared against L from the obtained data from part A. So by using the data that we recorded in the table, we are going to plot a graph t squared against L. So this is the graph that we have plotted. So from the graph, we are going to do some calculations in order to calculate the acceleration due to gravity. So first, for part A, we are going to calculate the gradient of the graph using the maximum and minimum length, maximum and minimum line from the graph. We are going to calculate the gradient, and for gradient, after getting the gradient, we are going to find the g value, which is acceleration due to gravity. So to find the g, we are going to use the formula that was given. So m equals to 4 pi squared divided by g. So when we substitute all the value inside, we will get g, a value of 2.06 ms negative 2. And then from that value of g, we are going to find the maximum gradient and the minimum gradient of the graph. After getting the values for maximum gradient and minimum gradient, we are going to use the formula of uncertainty of m divided by gradient is equals to uncertainty of gravity due to acceleration and g. So we will get the value of we will get the uncertainty of gravity, which is 0.16 in this experiment. So finally we can answer that answer the gravity due to acceleration due to gravity is 2.06 plus minus 0.16 ms negative 2 based on my experiment. Whereas the calculation for part B is the same as calculation for part A, but we don't have a graph for part B. So first we calculate the acceleration due to gravity using the given formula, which is T equals to 2 pi times with square root of L divided by gravity. So after substituting all the values inside, we will get acceleration due to gravity is 9.87 ms negative 2. Again, we have to find the uncertainty of the acceleration due to gravity. We use the same formula as uncertainty T divided by T is equals to 1 over 2 times by uncertainty L over L plus uncertainty G over G. So after substituting all the value, we will get the uncertainty of G is equals to 0.9 ms negative 2. So the final answer will be 9.87 plus minus 0.91 ms negative 2. So that's all for our analysis of our experiment. Next up, we are going to look at the discussion of this experiment. So for discussion, this experiment is generally conducted to study the demonstration of motion of simple pendulum in determining the acceleration of gravity and simple harmonic motion that is involved. So in physics, simple harmonic motion is referred as a repetitive movement of through an equilibrium central position, so that the maximum displacement on one side of the pendulum is equals to the maximum displacement on the other side. So this experiment is conducted to calculate the acceleration due to gravity. So for part A, experiment part A, the pendulum was released from an angle of 10 degrees because the usage of small angle proved that relationship between period squared and the length is linear. So when we draw the graph of t squared against L, a length, will be a straight line graph, a linear graph. So when the pendulum is oscillated 20 times and the average time for one oscillation is acquired, this is because to reduce the error during the calculation of time, measuring of time. So for this part A, the G was obtained from the gradient of the graph, which is t squared against L, and the value is compared with the equation provided, which is 4 pi squared divided by G. So the graph proved that as the length of the pendulum increased, the period time taken for the pendulum is also increased. So when the pendulum is propagated from a smaller angle, which is in the experiment is 10 degree angle, it is supposed to experience simple harmonic motion, and the acceleration obtained from the graph should be very close to the standard value, which is 9.81 ms negative 1. But the G value that obtained from my experiment or my graph is an impossible value, because the value that I obtained is 2.06 ms negative 2, which is very far from the standard value of 9.81. This may be caused for many errors while conducting the experiment during reading or recording the data results. Whereas in part B, the length of the pendulum was fixed at 1 meter, and the angle of propagation of the pendulum was increased to 70 degrees angle, and the pendulum was oscillated 5 times. So the period time of the pendulum is calculated by dividing the total time taken by 5 times. So when compared to part A, the motion of the simple pendulum is not supposed to be in simple harmonic motion, because as it oscillates in a very large amplitude due to the large angle. But from the gravitational acceleration obtained from my data is really close to the standard value, which is 9.81, but the value that I obtained from the data is 9.87. So the presence of simple harmonic motion is present in part B, whereas the simple harmonic motion is not present in part. Finally, we are going to look at the precautionary steps used throughout this experiment. The precautionary steps are carried out is the experiment is repeated. So the readings of the time taken to complete the oscillation is to obtain uncertainty. The repetition is occurred to obtain uncertainty, and then to reduce the error when recording the data. Next is the recording in the table. The significant figures of the data is made sure is the same among all the values in the table. Significant figures of the data in the table must be same. Next, 0 errors were checked in the apparatus before using them, and lastly, the time taken for one complete oscillation or the one complete oscillation of the pendulum is closely observed to make sure there were no mistakes or error. So finally, for the conclusion, we are going to look at this experiment was able to determine the acceleration due to gravity due to using simple pendulum in simple harmonic motion, and we were able to investigate the effect of large amplitude of oscillations, and I have also learned and understood the correct method to calculate the acceleration due to gravity from the data observed through the plotted graph. I also learned the relationship between simple harmonic motion and gravity. So that's all for my case study experiment. Thank you.